how do we find that total surface area? How to find total surface area? Find area of two triangles, and then after that find the area of the three rectangles, right? So the two triangles are the same, so 2 times of half times 6x small x. Okay, then after that plus the area of the rectangles, so we have one that is 6x times h and 2 of it that is 5x times h. Okay, then after we get that it is going to be 24x squared plus 16hx, but that is not what we want. 2 6xh, are you sure? There's only one panel that is 6x. You said 3 rectangles, right? Right. Correct. Okay, so we need to substitute h value into it. What is 16 times 375? 6,000. Okay, so we will get the required equation. So shown. Okay, then after in part 3 we want to find the first derivative of the area. Then after that, part 4 we want to find the stationary value of A. Alright, so first derivative. That will give us 48x squared minus 6,000 over x squared. Then after that, that is for part 3. So we want to find stationary value, so that means that this will have to be equals to 0. It's 48 what? Oh, sorry. X equals to 5, and then we want to find the stationary value of A. So x equals to 5 is not the stationary value of A. Okay, so we need to substitute it back in. So A will be that will be equals to 1,800. Okay. So in this case, the question did not ask you to find the maximum value of A. Okay, they only say find stationary value of A, then this would be sufficient. If the question were to say that it is for you to find the maximum or minimum, okay, maybe say for example maximum value of A, then you need to do the second derivative test, okay, to show that it's going to be the maximum. Okay, but I don't know whether in this case is it maximum or minimum. Alright, I'm just giving an example. Okay, so if the question phrases it in this way, then need to verify using second derivative test. Yeah.
For this kind, what are we finding? The derivative.
We want to find the derivative of A. That means we want the find. Let's see, what do you mean? Find the maximum value of A or stationary value of A. That means A is the surface area, the maximum surface area, no? Or the minimum surface area, no? That you put for this particular question, no? To give you a volume of 4,500. Okay, so maybe what's the use of this kind of question? Okay, for example, if you have maybe a certain item that you want to pack, okay, into a certain box, then after that, this item will have a volume of 4,500 cm3 and it will come in this particular shape. Okay, then after you model it with this particular equation. Okay, so this equation is being discovered based on the size and the shape that's going to happen for this particular object. Okay, then after that, you want to find the maximum area of this packaging. Okay, or you want to find the minimum area. So if you're looking at a business perspective, okay, surely you want to find the minimum area so as to be able to give you this same volume as well. Because you don't want to give so much packaging into the, you don't want to spend so much money into the packaging, alright, as a businessman. So then you will want to go about finding a minimum area. Okay, so in this case, I don't know whether it will give you a maximum or minimum. Right, it might give you a minimum value. So to find that, you know, x equals to 5, is it going to give you minimum? Right, then you do a second derivative test to prove it lah. Then that's will be how you can find out what is the dimensions of this box. Alright, that will give you the minimum surface area. Yes, yes. Can second and first derivative test be used interchangeably? Okay, so we have already addressed that second derivative test is only for you to find the maximum and minimum, whereas the first derivative test will allow you to find the point of inflection as well. Okay, and it is not always the case that the second derivative test will give you the maximum or minimum, because we said that if the second derivative gives you the value equals to 0, you cannot jump to the conclusion that it will be the point of inflection. Okay, because second derivative equals to 0, it can still give you all the 3 options and you need to verify it using the first derivative. So second derivative is a convenient way, but it's not a foolproof way. Okay? Yes. What does this value mean? It means that because we don't have the max, we don't know whether it's a maximum or minimum, so it's just a stationary value. It could be a maximum or minimum. Okay? Yes. So in this case, it could be a maximum or minimum. Right? I doubt that it will be a point of inflection. Doesn't have much sense to that. Okay? Alright, any questions? Yeah, this could be a maximum area or minimum area for you to have the same volume, 4,500, with that particular shape. Okay? Understand? Any questions? No? Okay, so with that, we will end chapter 16.2. Okay, then homework question 5, 8, and 9. I only have 10 minutes. I think I'll just give out your homework first.
I don't know.